you need to calculate the value of x. In triangle PQR, ST parallel to QR. Find the value, calculate the value of x. This is x. TR is x, PT is 10, PS is 5, and SQ is 2. For 3 minutes. Let me give you 3 minutes. Thank you. Go. Thank you very much. Thank you very much. Your time has elapsed. So let's check the solution. Check your work against mine. I gave you 3 minutes to work this one out. It was an easy exercise. Remember the theorem. A line drawn parallel to a side of a triangle cuts the other two sides so as to divide them in the same proportion. That is very much important. And when applying the theorem, the order in which you take the sides becomes even very much more important as well. The order in which you take your sides is very much important. Check. In triangle PQR, ST parallel to QR. Calculate the value of x. Here is x. Now we start with the ratio. If you take x over 10, very much important. X over 10, the order is important. I still want to maintain order is important. X over 10, 2 over 5 is equals to 2 over 5. Now for us to solve x, you need to multiply by 10 over 1. What do you do on the left, you also do on the right. 10 cancels 10, you are left with x. So you simplify there. 2 multiplied by 10 is 20, divided by 4. By 5, I think it will give you 4. So x will be equal to 4 centimeters. We include the units here because units have been given as centimeters. So it means x will be equal to 4 centimeters. That was an easy one. But that's how we start. We start with the easy one and then we proceed to the more challenging ones. Teachers, please let us be careful when coming to this proportionality theorem. Let's expose our learners to as many work as possible. Our learners must be able to solve these problems on their own. Thank you. For 3 minutes, so let's solve that one. What's indicated, what's given there is that in triangle ACE, BD is parallel to AE. Calculate the value of y. That is the value of y. There is y. Here is y. AB is y. We've got CD is 24. DE is 18 centimeters. AC is 35 centimeters. Your task is to find y. I think 3 minutes would be enough for you to go through the solution. I'm giving you 3 minutes again. Thank you. Welcome back, welcome back, welcome back. Now we're starting to enjoy Euclidean geometry. And remember, I said this topic in paper 2. Paper 2 will be out of 150 marks. Euclidean geometry is going to take plus or minus 50 marks. It's a lot of marks. You cannot afford to lose those marks. That's why I'm humbly requesting teachers, give learners lots and lots of exercises and take them through those solutions step by step. Thank you. Let's solve this one. In triangle ACE, BD parallel to AE. BD parallel to AE. Calculate the value of y. There is y. What is important is the order. Y over AC. I'm just taking y over AC. The very same order is again simple. If you take y here, you'll take DE on this other side. You'll take DE over AC is the whole side. This side you'll take CE. CE. Let's substitute. Let's substitute y over AC is given as 35. DE. Check DE 18 over CE. CE, you add the 2. 24 plus 18. I think 24 plus 18 will give you 42. Definitely it will give you 42. 42. Now we solve for y. Let's multiply both sides by 35. What you do on the left, you also do on the right. Thank you. Now 35 will cancel 35. You are left with y. Check 18 over 42. Multiply by 35. I can see you're already rushing to your calculators. You can work it out. Remember, it's a multiple. Basically, if you can take the multiple of 7. 7 into 35, common factor here. 7 into 35, 7, 14, yes, 28, 5 times. It's 5 times, and 7 into 42, it goes 6 times. Now we can still even simplify it further to say 18 divided by 6. 18 divided by 6, I think it will give you 3. Then you have 3 multiplied by 5, which is equals to 15. What are the units used? Centimeters. Therefore, the value of y is equals to 15 centimeters. Teachers, my humble appeal, give learners lots and lots of exercises on this. Because through exercises, doing those exercises, they will become more and more perfect. Because in mathematics, we believe in practice makes perfect. Clear? That was the first theorem that I wanted to discuss with you, and the theorem is called proportionality theorem. And in proportionality theorem, that's the theorem that states a line parallel to a side of a triangle cuts the other two sides so as to divide them in the same proportion. I strongly believe later on today you'll also be exposed to exercises in Euclid geometry whereby we'll be combining all the grade 11 theorems, grade 10, grade 9 theorems together with the grade 12s. They'll be put together, but at the moment I'm only specifically focusing on the grade 12 theorems. The first theorem that I've done for today is the proportionality theorem, which states a line parallel to a side of a triangle cuts the other two sides so as to divide them in the same proportion. Thank you very much. I think the similarity theorem states the corresponding sides of two equiangular triangles are in the same proportion. Let me write it down. The corresponding sides of two equiangular triangles are in the same proportion. The corresponding sides of two equiangular triangles are in the same proportion. That is the theorem that I want us to prove together. Theorem, a statement that can be proved to be true. So the statement that is given is that the corresponding sides of two triangles, we talk of two triangles, the corresponding sides of two triangles, let me underline that, two equiangular triangles. Let me draw the two triangles. Let me draw the first triangle here. Let me call this triangle A, B, C. And I've got to draw another triangle, and the two triangles must be equiangular. Let me draw a triangle. And this triangle, I can call it triangle D, E, F. I have deliberately drawn the two triangles so that they shouldn't be of the same sizes. So what is the given information? It's given that the corresponding sides of two equiangular triangles. Equiangular triangles. What do we mean by equiangular? Equi from the word equal. Angular angles. Equiangular triangles means the corresponding angles of those two triangles are equal. Equiangular, equal angles. What does that mean? It means angle A is equal to angle D. Can you see that? Angle C is equal to angle F. Mark them same way because they are equal. We need to mark them in the same way. Then angle B, let me make a smaller circle. Angle B is equal to angle E. Thank you. That is what is given. We've got triangle ABC and triangle DEF such that angle A is equal to angle D, angle B is equal to angle E, angle C is equal to angle F. That's the given. What are we required to prove? The theorem states the corresponding sides of two equiangular triangles are in the same proportion. It means the sides, if the two triangles are equiangular, their corresponding sides must be proportional. They must be in the same proportion. It means AB, which is the required to prove part, because we want to prove the theorem here. We want to prove the theorem required to prove part. We want to prove that AB over DE is equals to AC over DF. Order is also important. You can even go further and say BC over EF. That is still acceptable. But for examination purposes, we believe we'll only have that one. Just to prove two pairs of sides to be proportional. But in reality, the three sides, all the sides are proportional. If the corresponding sides of two equiangular triangles are in the same proportion. If two triangles are equiangular, then their corresponding sides are proportional, meaning that AB over DF is equals to AC over, I'm sorry, let me start like AB over DE. Let me be slow. AB over DE is equals to AC over DF is equals to BC over EF. So let's prove the first two pairs. We want to prove that in the two triangles, AB over DE, AC over DF. It means we want to prove that the sides are proportional because we are given that the two triangles are equiangular. Their corresponding angles are equal. So we want to prove the sides to be proportional. Clear? Let's construct. Sorry for that. Let's construct. Construction. Let's mark off AG on AB such that AG should be equal to DE. Let's mark AG such that AG is equal to DE with G on AB. Say it's G here, such that this side is equals to that one. Again, let's mark off again AH such that H is on AC. Mark off AH to be equals to DF. This side is equals to this one. So we have that. This is H here. That is H here. Let me call this angle B1. Thank you. Angle G1. Thank you. Then proof. What is that you want to prove? Remember the required to prove part. We want to prove that AB over DE is equal to AC over DF. Let me ask you a question. Look at this triangle, AGH. Look at this triangle, DEH. What can I say about the two triangles? What can you say about the two triangles? Triangle AGH, triangle DEF. What can you say about them? Thank you. Let's work it out. I think we have to prove congruency between the two triangles. Do you still remember the concept of congruency? Congruency, which means equal in all respect. Thank you.